Hello. So here we are doing some more geometry tutoring. So today I'm a little better organized, know what's going on, understand the technology a bit better, so I'll go ahead and begin just going over some examples for trigonometry. And if anybody has questions, then feel free to write them in the live chat. So starting off, trigonometry is here. So it's all about right triangles. So here I've drawn a right triangle, so then I'm going to label my sides. The way that we label the sides is we go to whatever our angle is in question, and we go straight across from that angle, and the side that is straight across from that angle, that side we're going to call the opposite side. So that's opposite. Sorry, I've got a bit too much volume coming through here. Let me mute that. All right, so now that's our opposite side. Now from the 90, we do the same thing. So we go from the 90 straight across, and we'll call that our hypotenuse. All right, and then the other side that's remaining, it is right next to this angle, but it's not the hypotenuse, so it's adjacent to the angle. Adjacent means right next to, so we're going to call it adjacent. That's the word for it, adjacent. Then we have our three basic trig functions, which we memorize using this little string of letters, SOHCAHTOA. So the way this reads is sine, so this is going to be sine S. So sine is going to equal opposite over hypotenuse. Sine equals opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now there are also inverse trig functions, and those are cosecant, and this is 1 over sine. They're inverses, which is also written hypotenuse over opposite, like this. And then there's secant, which is 1 over cosine, otherwise known as hypotenuse over adjacent. And then there's cotangent, which you could write either of a couple of ways. The first would be 1 over tangent, or adjacent over opposite. Now as it happens though, there's another way to write tangent, and I want to note that. This is also sine over cosine. It's another way to write tangent. And then cotangent would then be cosine over sine. Okay, so those are just our definitions. Now, once we've got the definitions down, then we go down here and start looking at some triangles with numbers on them, and we will start labeling them. So here we have our first example, and I'll leave all these definitions up here for the first example. So here we have a triangle ABC. We have sides AB, BC, and AC. So then from sine of A, so we're looking, all these are from angle A. So that's here. So for sine of A, that's going to be opposite, right? So we go from the angle, we go straight across, and that's opposite, which is 8. over hypotenuse, right? Because sine is opposite over hypotenuse. So then hypotenuse is across from the 90, so we go across from the 90, and that's 10. Now 8 over 10 is 2 times 4 over 2 times 5. The 2's cancel out, and we have 4 over 5. Cosine is going to work very similarly. We start from A, but instead of doing opposite, which would be 8, our hypotenuse is still going to go on the bottom, that's the 10, but our adjacent is the other side that's next to angle A, so that's going to be 6. And then of course that's 2 times 3 and 2 times 5, so the 2's cancel out and I get 3/5. Tangent is going to be opposite on top and adjacent on the bottom, which is 4 over 3. Now this next set over here, where it says sine B, cosine B, tangent B, I go from angle B. Now opposite and hypotenuse, these still apply. So if I'm doing sine, it's still opposite over hypotenuse. But if you look, starting from this angle, the opposite is a different side now from this angle. From here, 6 is the opposite side. But the hypotenuse is always the hypotenuse. So this one's 3 over 5. Now you'll notice the sine of angle B and the cosine of angle A turn out to be the same number. Now if we look at B and talk about cosine, that's going to be adjacent over hypotenuse, and we're going to find that that simplifies to be exactly the same as the sine of A. So cosine B and sine of A are the same. Cosine of A and sine of B are the same. And the tangent of B is going to be opposite over adjacent. And we'll notice the tangent of A and the tangent of B are reciprocals. All right, next example. So here, sine of M. So we start from angle M. And let's go ahead and do cosecant secant and cotangent as well. So sine of M, so I'm starting from M, the opposite side, right, from M straight across, the opposite side is 7, and then the hypotenuse starts from the 90, goes straight across, so the opposite, or the hypotenuse there is 25. So there's my sine. Now the cosecant, right, if we remember back from this definition up here, cosecant is 1 over sine, or hypotenuse over opposite. Right? So then, if we want to write the cosecant, it's just the reciprocal of this. We flip it. Okay. Now cosine, that's opposite, that's hypotenuse, so this must be adjacent, so that's going to be 24 over, and the hypotenuse does not change, it's still 25, which makes the secant 25 over 24. The tangent is going to be opposite over adjacent. Cotangent is the inverse of that. All right, well, let's take a look at a few more. All right, so from here, we have something a little different. We have an X here, but it's an angle measurement. So I'm going to use a similar functionality, right? I'm still going to use my trig functions, So from this x, I have here opposite. This would be hypotenuse, and that makes this adjacent. So here I have opposite and adjacent. Well, thinking back to my trig functions, the one that has opposite and adjacent is the tangent. So I'm going to say the tangent of x is going to equal opposite over adjacent. All right. Well, that's good, but it's still not going to tell me what x is. So what I have to know is that there is an inverse of each trig function. Right? Not a reciprocal. Reciprocals would be like cotangent. That's not what I'm talking about. I'm talking about inverse trigonometry functions, which you should be able to see on my phone calculator here. Here we have tangent, and if you hit second tangent, you should see it says like tangent -1. So let's write this down, and then I'll show you on this calculator. So what we want, since we have tangent of x, we want just x. So we're going to do this inverse trig function like this, tan -1 of parentheses 8/5, like this. And that's a calculator question. So we take our calculator and we do second tan. So it makes this tan -1 thing. Then we put 8 divided by 5 and close the parentheses. Now we do need to make sure that we're in degrees mode, right? So it's in degree mode, not radians. We don't want radians right now. And that's going to give us 57.99 degrees. So x equals 57.99. I'm going to go ahead and put one more. I like 5 spots. So 0.995 degrees. All right, let's try one more. So here I have x straight across. This is going to be the opposite side. From the 90 here we go across. That's going to be our hypotenuse. So here I have opposite and hypotenuse. So the trig function that has opposite and hypotenuse is sine. So the sine then of this angle is going to equal opposite over hypotenuse. But I don't want to know what the sine of x is. I want to know what x is. So to get rid of sine, I have to do its inverse. So I'm going to do inverse sine, or arc sine is another word for that. Arc sine. So I'm going to do the arc sine of 17/41. That is a calculator question. So again, I'm going to use that second function here. So I'm going to go second sine 17 divided by 41, close the parentheses, and that's going to give me an x value of 24.496 degrees. Okay, next we have here on example 5, now we've got a slightly different setup. We have an x now as one of the sides of this triangle. So I'm going to use the angle that I'm given here. So from this angle, this 50.1 degrees, I'm going to say x is our opposite side. From the 90, here's our hypotenuse, and that makes the other side here adjacent. So then from this 50.1, we have opposite and adjacent that we have numbers for. So then I could say tangent of 50.1 degrees is going to equal x over 5, because that's opposite over adjacent. Now here I want to know what x is, not what x over 5 is. So to get rid of this divided by 5, because that fraction bar means divided by, right? So to get rid of divided by 5, I'm going to do times 5 on both sides. This cancels out, and I end up with x equals 5 tangent of 50.1 degrees. And that, once again, is a calculator question. So we type that in. 5 tangent 50.1. We get x equals 5.9799, and then the next digit's a 3, so it rounds down. So it stays this. And that's not degrees, that's a side length, right? This x is a side, not an angle, so we do not put a degree symbol on that. Okay, now here we have theta. We have this 15 straight across from it's going to be our opposite side. Straight across from this 90 we have our hypotenuse. And then here we have our adjacent side. So what we're asked to find here is cotangent. Well, cotangent, that's going to be adjacent over opposite. Now if you don't remember that way, that's okay. We can do tangent first. So tangent should be opposite over adjacent, and then we can flip that for cotangent, because cotangent's just you flip the tangent. From there we're going to simplify. We see this is 4 times 5 and 3 times 5, so those cancel. So then our cotangent of theta is going to equal 4 over 3. All right. Couple more examples, and then if no one has any questions, we will call it a day. Let's see what we've got. Angles of elevation and angles of depression. So these, that's a little tricky to read, isn't it? Let's see if I can darken that a bit. So these are, it's glare. Okay, there we go. So these are problems where the angle you're given isn't actually inside the triangle, and you have to recognize what's going on based on knowing what the problem's about and using our other properties of geometry to identify an angle from inside. So what we notice here is these lines are going to be parallel. If we're talking about elevation and depression, this is going to be a horizontal line, like the ground or something on that order. Like this is going to be sea level or something like that in any problem that's about elevation and depression. So these are going to be parallel. Now, given that they're parallel, then we have these two parallel lines here crossed by this transversal. So this transverse line. So then this is 27. This and this angle here are going to be the same. This is 27 degrees here. The reason is they're both interior to the parallels, right? They're in between, so interior, and they're on alternate sides of the transverse line. So then 27 here, 27 here. So that's alternate interior angles. That's why this one's 27. Now from here, we say from this 27 here we have opposite, and from the 90 here, this is going to be our hypotenuse. And then this is our 580 yards, and then this is our x. So opposite and hypotenuse is sine, so I'm going to say the sine of 27 degrees equals opposite over hypotenuse, like that. Now from here, just like the last problem, we're going to do times 580 on both sides. This cancels, and x is going to equal 580 yards. Oops. 580 yards times the sine of 27 degrees, which is a calculator type problem. Get my calculator turned on here. So we do 580 times the sine of 27 degrees. And I remember we are in degree mode, so I don't need to worry about that. So then x is going to equal 263.31. Now this is a distance, and the distance we used to calculate it was in yards, so this is going to also be in yards. Okay, last example. Sorry, something popped up over here. Let's see what's going on. No, we're good. All right, so our last example here is a word problem, which is extremely common with angles of elevation and depression, extremely common in geometry overall, and in trigonometry, all over the place. So, and this is a pretty common one where the ground is one of your sides of the triangle. So let's take a look. Unsupported flagpole is 282 feet tall. Okay, so then let's start a drawing. Here we have our flagpole. It's 282 feet tall. We have a ground here. And that's going to be vertical because it's a flagpole. Of course it's vertical. So now, shortest shadow cast is 137 feet long. Well, that's going to be like this. And our triangle then is going to be like this, where the sun is somewhere up here, making its sunshiny rays. So there's our shadow. 137 feet long. So our triangle then is this. What is the angle of elevation to the sun when casting the flagpole's shortest shadow? So then our x is going to be here, because if you think, okay, well, here's me standing around looking, then angle of elevation means how steeply do I have to look up to see the sun. Okay, so that's my x, and that's going to be in degrees. So now it becomes exactly the same kind of problem as all of the other trig problems. We label our sides. Here's angle x, so this is going to be straight across from it, that's opposite. This one's going to be hypotenuse, which we don't actually need, and then the other one is adjacent. All right, so now opposite and adjacent is going to be tangent. So I'll do tangent of x is equal to opposite over adjacent. But I don't want to know what tangent of x is. I want to know what x is. So I have to use the inverse function, or the arc function. So I'm going to do arc tangent, or inverse tangent of, now these feet cancel, so I end up with just 282 over 137, which is a calculator question. Oops. Second tan, so arc tangent of 282 over 137, enter. So we have x equals 64.08, and then our last digit is 8, but the next one after it is a 7, so we're going to round it up just in case you need a refresh on your rounding skills. Now this x is an angle, and we have our calculator set to degrees, so we're going to call that degrees. All right, well, that gets us through our trigonometry lesson. So, opening the floor to any questions. If anybody has questions, you may type them in the live chat. wait just a couple of minutes to see if any questions come up. All right, well, we are going to call that a day then. I will not be streaming again over the weekend, but I should be up again on Monday if anyone needs help. All right, have a good one.